All right, everyone. Well, hello. Welcome to our webcast here today. I'm looking at our audience coming on board. Alexander, one of the first people to log on in. I've got Joy and Kyle out there in our audience as well, Lynette, and a whole lot of other folks. Can't go through everybody's name, but I can welcome you all collectively to our event. You're in the right place if you were looking to learn a little bit more about artificial intelligence, automation, and the impact that it is going to and currently is having on IT teams these days. James Hilliard here, host for this event, and really glad to have on board, and really our featured speaker, the guy that's the real smart one on this event, is Kevin Surace. He's a pioneer of artificial intelligence. I'm going to give you a little more background on Kevin here in a second, but the first thing I wanted to do, Kevin, is as we've got everyone coming on board with us, we're here talking about AI today. Is there a common misconception? Is there something that you'd love to clarify for a lot of folks regarding AI that you hear sometimes as you're out talking to people and you cringe just a little bit?
Yes, there are so many, James. Thanks for asking, and hello, everyone. Look, AI itself is arguably almost a term of science fiction or a term of marketing. What we're really talking about here is machine learning and using algorithms and basically math to identify things that happened in the past, things that have happened in our data that we can apply to future actions and take a pretty good guess at what might happen or what should happen, et cetera, to augment the way we think. That's what we're talking about. We're not talking about Her, the movie, although it's really cool. We are not talking about Ex Machina. We are talking about math that can work for you in far better ways than it did 5 or 10 years ago. And I think once you understand that, you go, oh, I'm not too scared of this. I can apply this across my business. And that's what this is about. And that's really what we want to talk about today is what can you apply in IT? What can you apply across your business? What are you responsible for in IT where you can really have an impact on your overall company's bottom line? It's really exciting.
Well, what we're going to do today, folks, I want to invite everybody that has joined us. Now, again, Eugenio, see you coming on board, Ellie, Grant, and others. Your questions, your comments. I had a chance, Kevin and I chatted a couple of times before this presentation, and he knows that while I do appreciate AI, I'm maybe 80% on board, but Kevin knows I've got a little bit of, but hey, what about this? So I'm sure I'll be bringing in some of those folks. If you've got some, hey, wait a minute, or if you're really on board and you've been doing something with an AI and you want to share that, Kevin, we encourage you to do so. Just use the Q&A module to type that on in. We'll mix in as much as we can in this hour. About 45 minutes of content with Kevin. Again, a couple breaks for some questions. Let me give you a little more background on him. So why Kevin here? Well, you know that little thing called Siri? And the technology behind all that? Well, yeah, he was one of those original inventors there. 84 worldwide patents in this area of AI, emerging software, all sorts of things. Currently, he spends his days still as a CEO and CTO. Appvance.ai is his current group. So he's in the thick of it, in the heart of it, and you're going to hear and I think demystify a few things as well here today. So with that, Kevin, I want to, again, thank everyone for joining us for this event. Again, brought to you all by Citrix. Get your questions and comments in. And Kevin, let's dive on in at this point.
Thanks so much, James. And, my big question to the audience would be right up front. What would you say to me if I started this and said, your job in IT is going to fundamentally change? You won't recognize it 20 years from now. You will not recognize what you're doing, how you're doing it, why you're doing it. Everything you've known about IT will change. And it's going to change because of machine learning, because of AI. And so that's why I think it's kind of the most exciting time. And by the way, if I had said that 20 years ago and said everything about your job will change because of these 3 letters, you would have said you're crazy. And I would have said, no, you'll be able to shop. In fact, you'll be able to take a picture of this screen and send it to 1 billion people right now. And you would have said, that's crazy. It's ridiculous. How could I have a supercomputer in my pocket and carry it around and do all these things? But we do that today. And in fact, much of the job of IT over the last 20 years changed dramatically because of the internet. All of a sudden, we had to protect ourselves from it, integrate to it, get everyone's email to work worldwide, and on and on and on, right? And deal with spam and everything else. In fact, our entire job became really circled around the internet. And in fact, you couldn't have cloud services. You couldn't have much of what Citrix does today without the internet. Couldn't be done. And so our jobs entirely changed. And so you can't underestimate how much this is going to happen. We hear this term digitization, the digitization of everything. We're moving from an analog and a paper world to literally digitizing everything. And once everything is digital, we can do a lot more with it. That's true across the business. It's not just in IT. When we look at where AI is seeing success, it's all of these areas already. I'm going to give some examples today and also why they're important to IT and why you're part of it. But let me open with one of 100 articles that said every company is now a software company, because the real gains in productivity and profit are going to come from IT. That is, from implementing software that's very advanced to drive more productivity out of the people. We've already given them laptops. We gave them internet access. We gave them access to Microsoft Office and everything else. We are now at a time when we are going to have to get our gains in some other way. And it's not going to come from a cost reduction of some component. Now, before we get too far, we want to go back in history. You know, we've been automating for a long time. In 1969, there's the first ATM machine, and someone pulling some money out of the first ATM machine. Note, that was an IT project. IT at Barclays Bank, I think at the time, actually had to go implement this darn thing. And you can imagine, they said, what? A machine to replace a teller? It's impossible. It's crazy. Of course, we take this machine for granted. In fact, most of us don't use it anymore because we can take checks on our phone, right? Who would have thought? The American public became aware of AI, so to speak, really when Deep Blue won against Garry Kasparov at chess. Gary being a chess master, the best in the world. But what's fascinating about this is in just the 22 years or so since that happened, and since it was such a breakthrough, you know, any phone can beat you at chess inside the phone. It doesn't really need to go anywhere. It has the same algorithms, right? So, of course, in 2011, this is now 8 years ago that IBM Watson won on Jeopardy. This was done in a pretty simplistic way. Nevertheless, it was quite a feat, as you can imagine, for, again, the American public to go, this stuff is real. So we start to think that that's what we're building, but that's not what we're building. You know, what science and Hollywood like to talk about is general AI. That's the artificial James Hillard that is every bit as good as the real James Hillard, and I can't tell the difference, right? Or the artificial me. But that's not real, though that's the general public's idea of AI. It's not what we're doing. It's not what the professionals work on. What we work on in our industry is very narrow. It's driven by industry. It's one task. It's practical, and it's going to solve that one thing for us. And mostly, it's replacing some mundane work that would take a human or many humans a long time to do, and they might not do a very good job at it because it's just too much data. So it's working on a lot of data and taking mundane tasks and automating them. That's what we're doing. This is a great chart. I like this. AI's had a long history, as you can see, and we really got into narrow AI since the 80s. And we've made great progress, and deep learning came in by 2012. There was a big learning experience there, and reinforcement learning. We'll talk about some of those today. But the concept of general AI, which is human level intelligence and EQ and all of that, you'll notice what the date is. Unknown, right? So James, there's nothing for you to be worried about, right?
And that's where I think people do worry. And after you and I talked the first time, I recalled a conversation I was having with my kids recently. I'll go with my older one, a high schooler, freshman. I was telling him that he may be working in a job that has not been created yet. And a lot of people worry that AI is going to take over, and then what are we going to do? We're all going to be, out of work and not doing anything. But the new jobs just haven't been created yet. And I'm starting to envision the idea that AI will allow us to explore what are those new opportunities and new works.
I give a different presentation that just talks about all of the hundreds of new jobs that we already are starting to need. And I'll give you a couple of examples. We're not going to talk about them really today, but a transitionist. What's a transitionist? If you've got thousands, hundreds of thousands of companies that have to take their people and transition them from what they were doing, very IQ-based, to what they're going to be doing, which might be very EQ-based, you actually need people to get them there. It's kind of like a corporate psychologist. It's called a transitionist. And we may need hundreds of thousands of those. How about drone planners and operators? If you've got drones using imagery and taking in this imagery and using AI to identify abnormalities or crops and field issues or whatever. Now you need people who plan the drones, decide where they go, why they're there, who's going to pay for them, etc. So now you do have an entire new field that we didn't have 5 years ago of drone operators, basically, and drone planners that might be hundreds of thousands of people over the next several years. So there's two examples of this technology coming along, and all of a sudden it creates brand new jobs that we didn't have. So I want to talk about machine learning a little bit. Most of us hear about deep learning or reinforcement learning. I'm going to talk about some of those, but I want to tell you that most of the great work today, much of the great work, is happening because of very traditional machine learning, and this traditional machine learning getting applied in the cloud, where we can rent essentially what was a Cray computer. For those that are old enough to remember that, we can rent one of those. You know, we can rent a 1,000 CPUs for something like $10 an hour, some ridiculous number, right, at AWS or Google or whatever. So once you can do that, all of a sudden these machine learning algorithms that used to take years to work start to work for us in an hour. And that starts to be a magic number for us, right? So just know there's lots and lots and lots of these, and there are lots of reasons to go Bayesian or decision tree or dimensionality reduction. And you don't have to be the expert in this, because there are lots and lots of companies doing this, as we'll talk about in a moment. So when we break down machine learning into all of the different parts of machine learning, the one we like to talk about of late is deep neural nets, both recurrent and convolutional. They're actually pretty easy to understand. I'm going to explain them in a moment. And then reinforcement learning. So let's talk about those. These tend to be used mostly for image recognition, speech recognition, translation, things where there are very, very large amounts of data. As you'll see on this chart, traditional ML works with very small amounts of data. In fact, it works better than anything else we have on smaller amounts of data. You have to have very large amounts of data to use the other ones. And regardless of which direction you go, you got to find, first of all, an excellent data source. You got to sort that data. And this turns out to be hard in every company, because companies have changed databases and changed tables and added things to it. And finally, you got to find that needle in the haystack. And I can assure you, finding a picture of a guy finding a needle in the haystack happens to be just as hard as finding the needle in the haystack. And then you got to be careful of what you find. And this is why now there are entire fields of humans looking through what AI found to say, this is actually important to us, or this is garbage. I know a company that was working on analyzing some early markers for breast cancer, and they found some 34 that were really highly interesting that came out of AI, but 33 of them were absolute nonsense. It wasn't wrong, it was just a correlation that couldn't possibly make any sense, right? It correlated it to the phase of the moon or something. And I'll give you a couple of examples of bad correlations, right? So here we think this might be a bad correlation. It's really a correlation. It turns out that over this time frame, the age of Miss America correlated very well with murders by steam, hot vapors, and hot objects. Now, James, I don't know about you, but unlikely to be a real correlation that we care about, right? Probably not. Very unlikely. Now, this next correlation could be true, that suicides by hanging, strangulation, and suffocation go up as the number of lawyers in North Carolina also goes up. This might be an actual correlation. I say this because I doubt there's any lawyers tuning in today. But nevertheless, we have to be careful. You're going to find a lot of correlations that make no sense. Let's go on and talk a little bit about the three sort of bigger, broader areas of machine learning here. We've got supervised, unsupervised, and reinforcement. And supervised and unsupervised don't mean that you watch it or don't watch it. That's the obvious one. Oh, well, I'm watching it, therefore it's supervised. No, you're not the babysitter of the machine learning. Basically, here's an example of supervised. I give it right here. Let's say you trained the AI with labeled photos, so they have names on the photos, and then you want AI to place names on new photos. So I had the answer, which is why I'm looking for the function, and I've got X, which are the photos, right? So I've got the photos, I've got the answer. Now I'm looking for a function to match photos to answers, photos to names, that is. That's supervised. Unsupervised is I don't have the answer. All I have is a pile of data, and I want to know a function to find out something, maybe like data. So I have no labels on those photos on the next one under unsupervised, and all I can do is cluster those or associate them, right? So now I can sort the photos into piles of the same person. Of course, I cannot give any of them a name, because I was never given a name to learn from. Does that make sense? So we can work on supervised data and we can work on unsupervised data. Both really cool. Nothing wrong with it, but you're going to find different things in the unsupervised pile versus the supervised pile because I can't match them in name. And the last one I want to talk about in this section is reinforcement. And reinforcement is based on a simple reward where you observe, you select an action using a policy. I'll explain that in a second. You take that action, you get basically a reward when things go well, and you get a penalty when they don't. Then you update the policy, and in other words, you keep learning, you keep building out your neural net, and then you do it again and again and again. Now, why this works is because a computer can do something millions of times, possibly in a few minutes, possibly in a few hours. And any of us can learn something very well when you do it millions of times. And the great example is the mouse in the maze. Bell rings, the mouse doesn't do anything, but over the course of several months, learns that when the bell rings, there's cheese in another corner, and it goes and gets the cheese every time. Now, how does it learn to do that? Well, it had thousands and thousands of tries to eventually find the cheat. This is reinforcement learning. That mouse is really dumb. All it knows is I get a reward. And that's what we based reinforcement learning on. By the way, if I put a second mouse in there, the second mouse thinks the first mouse is a genius. But of course, the first mouse has no larger brain than the second mouse. It just got to do it over and over again. This is a great example from our friends at Unity Games. This is Pikachu versus the trucks. Now here, the Pikachu only has to get the presents, and it gets a reward when it gets a present. Note, there is no programming that taught the Pikachu how to play the game. There's no AI hinting in this. It was simply a reward. You get a reward when you get a present, and you get a penalty when you hit a truck. And so it's building up a neural net by itself. We don't know how exactly. It's building a large neural net of how to avoid trucks, basically. It learns by itself to avoid trucks because all it wants is the reward. Very simple programming. Makes sense? And it can go very deep. Now, what's interesting about this is after 6 hours, it begins to play at superhuman capability. In fact, it now can outplay this game forever and will never, never be hit by a truck. In fact, it's so good that we could just stop right now because this will play for the next 2 hours like this, and it'll never lose. So this is a very good example of reinforcement learning. James, while we move on, any thoughts? Let's stop here if there's any questions.
Yeah, there are just two. One, back to the idea of supervised and unsupervised. It sounds like then if we train incorrectly, then the systems will learn incorrectly, and they could not overcome that. They only go on what we've given them.
That's absolutely right. This is so key. Remember when I said you've got to give it good data, sorted data? Do you know one of the biggest problems in AI? We train it on bad data, and you know what we get? Bad outcomes, bad forecasts, bad everything, because it doesn't know any more than what you trained it on. Excellent question.
And then with this, if we started the game again, would Pikachu always do the same route, or would it try to learn a different route that might be more efficient, or does it say good enough?
I love it. The Pikachu actually didn't learn any particular route. What it learned to do is avoid the trucks. And that's because that particular game is randomly seeded, so the trucks will start coming in. If you started the game over, the trucks would start at different places and come at you in different ways. But it learned probably by then, every avoidance technique of avoiding a truck. It learned to back up, it learned to go to the side, it basically learned to outrun the trucks. Because the game was meant for a human, of course, at human speed, and now after thousands and thousands and thousands of plays, the computer can just beat it. So no, it didn't learn a pathway. It learned avoidance techniques. And I have other examples of that. We're not going to show them today, but that's all it's learning is avoidance techniques. And you go, okay, that's pretty good. Now, that's applicable to the future. If I had a different kind of game, but it had a very, very similar infrastructure, it could start already having avoidance techniques of trucks, for example, right?
Excellent. Excellent. Chloe, Alexander, a couple other folks are getting some questions in. I'm going to look through those. I know, Chloe, we can talk about a bit later on, and I want to look on something on Alexander's question, but let's keep on cruising forward, and we'll come back to a few of those.
Let's talk about image recognition. I just want to share with you how hard this really is. I mean, we take it for granted now, but on the left is a Chihuahua. On the right is a blueberry muffin. One of these is edible. The other one, do not eat. You choose, okay? Now, if I told you to recognize these, you can obviously recognize one as a little dog and one's a blueberry muffin. But if I then gave you just 3 seconds to count the blueberry muffins on this page, you would not be able to do so, because the blueberry muffins start to look an awful lot like Chihuahua. And that's been the problem with real image recognition. Things look like other things with shadows and angles, and start to recognize a fox from a dog, and it starts to get pretty hard in some circumstances, right? So we've gotten very good at it. How we've gotten very good at it is this kind of deep neural net reinforcement learning, and it learns from very, very, very large databases. I mean, we used to recognize faces like that, and now we do it like this on the right today. Facial recognition is a given in Facebook. In fact, our machines have gotten so good at image recognition now, they're about twice as good as humans at overall image recognition for the things they've been trained on. So that's really exciting. Let me go on a little more, and then we'll take these couple questions if they're in. So, just some little background, because you'll hear these terms. Overfitting is a bad thing. What we're really doing almost all the time is we're curve fitting, right? We're trying to match what happened in the past to what we're going to see in the future. And if you write these algorithms too tightly, like the green thing, we will never find anything that fits that green curve in the future, right? That would be overfitting. We're going to find things that fit the yellow. So if you hear the term overfitting, you just kind of know that's all this is, you know, and you don't have to do the math. There's experts who do that, but you just sort of know what it is. Black swan events, it's talked about all the time. These are just rare and unpredictable events. I happen to be in Florida right now. The chance of a volcano dumping lava on me would be zero. And in fact, there is no time in history that's ever happened in Florida. So any models we have of Florida traffic and Florida people and people on a webinar in Florida have no analysis of what would happen if lava flies into the window, right? So we couldn't model that, and AI couldn't model it. It'd be better to have a human predict the bad outcome of that than models, because it's a black swan event. It's rare, it's unpredictable, it's not in the data. The other thing is fast-changing patterns create a lot of noise. So, you know, if you go out and scan the world's applications and try to find some commonality in them, what you find is there may be almost no commonality, because every application has a different purpose. It's designed by a different team. It's designed using a different library, and it might have been designed and built at a different time. So the amount of noise in that data set is just enormous. It'll be very hard to cull interesting things out of that. And so you might not bother. It might be a complete waste of time. And the last is biased data. Why do we have biased data? All data was entered into the systems by humans. All data was created by humans to date. Biased data has already come up a lot in using AI in HR. This is probably not a surprise. And I'll just give you an example. I'm a graduate of Rochester Institute of Technology. If I'm interviewing someone and they say, hey, I'm from RIT, I already have a confirmation bias. I already have a bias that I'm likely to hire that person. Why? We've both been in Rochester, New York. We both know what the school's like. We both blah, 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 right? We can just go on and on. And so those confirmation biases are in the data. And so when you use AI to make hiring decisions, and what you're trying to do is say this, go find the kinds of candidates that made it to the VP level in our company, let's say, right? Well, what happens is all of those incoming candidates were already biased by a whole set of things during the interview process that we can't get out. It's very hard to get out. So now there's a whole field, by the way, of unbiasing data, trying to go through it and equalize it and normalize it. So you can see these are some of the problems that do come up. Let's stop for a second before we get into robotic process automation. James, anything or any comments?
Yeah, so let me go back to Alexander, and this goes again back to kind of the supervised, unsupervised. The board game Go, it's one of the oldest board games out there, developed in China 2,500 years ago or so, was beat by a computer. It was AlphaGo, I think was the program that beat it. Right. He was just wondering if you know anything about it, and was that a supervised type of event?
Oh. Well, it's a very, very good question. I wasn't on the team. I know some of the people who were on the team. That's something that Google worked at for many, many years. Go was thought to be unbeatable because it has millions and millions of combinations, right, and outcomes. However, part of what they did was study as many games as they could from the past and all the moves that were made for the past. And since those games had an outcome, what was it? That was supervised learning. Now, they probably use both supervised and unsupervised, because not only would you want to study all the games that had been won and how they were won, you would want to study all kinds of other combinations and who might have won. making up games, right? We're actually creating AI-driven pathways, right, that are all randomized but still have an outcome. And so in the end, you're creating a supervised set, and then you're learning from that on why one won over the other, right? Even though both might have been generated by the computer. There could be only one winner. It's a fascinating problem, but I think all of us thought it might have been unsolvable. But again, it turns out in fact, in that case, billions of plays inside the AI, it was able to get better and better and better at predicting far down the road, hundreds of moves in the future, what this move would impact. And in fact, it got just beyond what a human could do.
Brett just making a comment, and then we'll get it back to you. But he was saying, and I'm going to bring this up because I remembered, and it's bringing back good memories. Brett's saying similar to the outcome of the movie War Games back in the 80s, if you remember that, Kevin.
I do. I was already 82 at the time. Yeah, no, I was young. Yes. Well, War Games is interesting. Of course, in War Games, they turned over to a computer, basically AI, to make the decision on whether one should launch a strike or not, or launch a first strike or whatever. Right. I think we're unlikely to do that for a very long time. As we've learned just from the, sort of Boeing 737 MAX issue, turning something over to software and not allowing it to be wrestled back ends badly. In both cases of those jets going down, had the pilots been able to wrestle control back, they would have saved the plane. As, by the way, you may not have read, as happened one day before, they were able to wrestle it back. Someone knew how to turn off the system, and the plane flew fine all the way to its destination, right? It was a software malfunction, turn it off, keep going. But our systems aren't perfect, but they can be very, very good at certain things. So look, let's go on to robotic process automation very quickly. What I love about RPA is that it's an IT project, but it doesn't directly interface to the APIs or anything else of your systems. It basically takes the role of a human, basically another program on top of your existing software, and it pushes the buttons basically the way a human would. So this is great for insurance claims processing, where you've got maybe 14 applications that have to be added, and this move to here, and this data pull, and people are doing that today. So tasks that are very repetitive can be really handled well by RPA. One of the bigger companies in this is Automation Anywhere, but there are many companies in the space, and this is being rolled out in so many companies today. I highly recommend you looking at that. What I'd like to do today is I want you to think about AI as augmented intelligence, and these are just some of the startups that can provide product to you today in a variety of areas around your technology stack, and you can see them. If you wanted to do natural language or specific machine learning or data science or data capture or different industries, investment, education, there's unlimited. You do not do this yourself. You go out and find people to do it for you. Now, I'm going to give you some examples of the simplest automation. This is the simplest form of automation. There's no AI at all. Enter your own order. And it turns out just that alone saves labor by 40%, improves order accuracy to 100%. This is the Savio Towel Butler, of course, in some Bay Area hotels. And what's nice about this is the manager figured out right away, let's put Starbucks coffee in it instead of hot towels, and it became even much more popular. This is an office robot. I want you to know that all of these are IT projects, whether it's the hotel or whether it's this office. These are owned by IT. And this robot goes around and checks security, makes sure doors are closed and lights are off, et cetera, et cetera. You decide if it's valuable or not, but these are things you could buy today. You could buy the Cobalt robot. This is an excellent robot. It's Nightscope, probably the best known in security robots. They are in the Bay Area. They're Mountain View, and the robot is the white thing. I'm the one with the cool shirt on, and that's the Stanford Mall, and that particular robot has multiple cameras, multiple sensors, and it's great because in the middle of the night, nobody wants to walk around a parking lot at 2 a.m. and be the parking lot guard, and there are hundreds of thousands of those people. But things do go wrong, even with robots, with sensors, modern robots. Here's an example. This guy was arrested after attacking the armless security robot. In truth, he lost his job the week before to the Nightscope robot, got drunk, came over and beat it up. This is absolutely true. Obviously, the police found him 5 minutes later. That's ridiculous. You can't beat up a robot. This one's sad. Even robots commit suicide. Sometimes robot security guard committed suicide in the fountain. Even they have a tough life. But we're seeing robots in other places. For instance, to keep the elderly company is a great example of robot use. But let's talk about some things that you can do today, some things that are being implemented today and how cool they are, if I can. We talked about crops a moment ago. Almost all major farms are now using drones and AI to understand where they need more fertilizer and where they need less fertilizer, because that saves them real money. In healthcare, this is a project by Google at a few hospitals. What they did is go back and analyze hundreds of thousands of patients incoming, maybe millions now, and whether they lived or died. And now they're predicting when you walk in within a few minutes, are you likely to live or die? Now, they don't give you that information. We're just trying to figure out how close can the AI guess, just on incoming admission, whether you're going to survive or not. This is Addison. This is another sort of keep the elderly company and get them to take their medicine and this is a real big problem because there aren't enough people really worldwide to take care of our elderly as with an aging population. So this kind of simple technology is very valuable. It keeps them company. They feel like there's someone there, and it's helping them. It says time to take your blood pressure, time to take your medicine, time to exercise, as you'll see in the next one. So really fascinating, very straightforward, and can use natural language processing. You can actually talk to it. So you're going to see more things like this. You'll see this isn't a physical robot. It's kind of just on the screen. Workday, many of you have Workday. You may know you can turn this feature on. Every manager and all the way up to the CEO can see who is likely to leave in the company next and why. Is it because they haven't gotten a raise? Is it because of bad management? Who knows, right? They've got a predictive algorithm. This is a legal assistant. Everybody's using digital legal assistants now. Here's a very good experiment that the Stanford University did. They put AI on analyzing a non-disclosure agreement and found it was 10% more accurate and 180 times faster than an actual lawyer. So again, this is a mundane task. Lawyers don't like to do it, and it turns out they're not that good at it. Now, I've picked on lawyers twice in this presentation. I'm sorry, this is not a presentation to lawyers. Otherwise, I take these out. But this is true. This is happening today. So why wouldn't you use AI to analyze your NDA? If you don't think people have trials going on, VW announced they have more than 100 AI trials underway right now, from material transportation to detecting defects, smart applications, conducting virtual product tests. Scientists are using machine learning to unlock the mysteries of long dead languages. This is interesting. That is clearly unsupervised. We don't know the answer, but we can start to see similarities. It's really fascinating. If you get enough of them and enough similarities, you start to say, well, this is interesting. I saw this here, and I saw this here, and I saw this here. And it starts to put together some framework of what the thing might be saying. Sadly, Netflix is now using AI to find illegal account sharing. I'm sorry, James, I'm sorry about that. I can't fix it. Scientists recently used AI to identify an unknown human ancestor. We knew there was one in there, but they found it, and they said, well, it's in this set, and because something contributed that to our DNA, and it's long been done. Attuned can figure out what motivates employees using a huge database of what they've learned from what's motivating other employees, and it helps you manage your employees better and work with them. Deep Scribe as AI-powered medical notes. You know, if you go to the doctor, he's always scribbling on something, and this takes that out. It uses natural language processing. It writes it for him. I mean, very, very useful, right? Here, Zest Finances uses AI to allow lenders to write loans to otherwise unqualified clients. Maybe someone declared bankruptcy, and in your rules, you'd say, well, they declared bankruptcy 5 years ago. I'm not going to lend to them. But this system can look at many, many, many more details and decide that actually it's a very low risk to lend to this person so they can expand their business. AI in intelligence, AI in manufacturing, this is great because it's being used with glasses as well as natural language processing to reduce or eliminate training, so that someone could be on the job without a one-year apprenticeship. They could just be on the job, and between the glasses, the cameras, the natural language processing, it will tell you what to do next, and it'll stop you from doing something bad. Absolutely fascinating, right? Software QA, obviously a big place in my heart right now. Spent 7 years working on this problem. Software QA for anyone in IT, as we know, is a little bit of the bane of IT's existence because we've got to deal with these problems. It's $80 billion to spend today on software QA. 95% of that is human labor. It's a big part of the IT budget across the world. And so you ask the question, if we could eliminate test maintenance, if we could automatically generate 6,000 scripts in 10 minutes, validate virtually anything in the application, find more important bugs, achieve near 100% code coverage, you get the point. That becomes the centerpiece of your CI/CD, your continuous testing process. And in fact, we're getting there. In fact, for many people on the system, they're already there. There are 5 levels of test automation, but there's 5 levels of autonomy in most fields. This happens to be for test automation. In driverless vehicles, level 5 means you can fall asleep. And in test automation, it also means basically you can fall asleep, mind off. It'll go off, it'll validate, and when you have a next build, it'll rebuild scripts, it'll retest it, it'll revalidate everything, and just give you the answers with virtually no human involvement. The productivity is just ridiculous as you get to level 5. I won't go through all of this, but kind of gives you an idea of what can happen. I think this is probably a good summary way to summarize QA is if you think about much of what people work on, it's regression tests, and you've got this pile of regression tests that took years to create, but are probably broken at every build and need some maintenance. But an AI system could create thousands of regression tests in just a few minutes and run them and give you the answers. And why would you want to maintain your tiny little pile? AI has been attacking cybersecurity for the last 2 to 3 years. It should be used across. I mean, you should be using this. PA Networks is one example of this. Drift is a really, really advanced kind of interaction with your customers. We've always seen these little bots come up on sites now. 9 times out of 10, those bots don't have a human behind them. They're going to interact with a human in a human-like way until it really needs a human. So absolutely fascinating. Customer service automation platform. 80% of customer service calls are answering the same questions over and over again. Once a platform can learn, once AI can learn what those answers are, it can begin to answer them, frankly, every bit as good or better than humans. And you can reduce that human labor cost there, right? Jill Watson is a teaching assistant, obviously based on Watson, and so many other areas. Virtual assistants, of course. I have a slew of patents in that area. Originally at General Magic, we had the first virtual assistant many years ago called Portico and MyTalk and Magic Talk and Mary, etc. Mary was her name. Purchase recommendations, etc. So let me stop right there. These are all exciting. We can do them today. James, any thoughts before we carry on?
The idea of these automated assistants, right? And they're talking to us and they're giving us the answers. And that's great, right? It's efficient, it's quick, it's there. It's a transaction. There are times, though, and I had mentioned to you before, I was traveling and I got to a hotel. I could easily check into some type of robotic system or kiosk or something that could maybe even talk to me. But I joked around with the guy at the counter, and that lightened my mood. I'd had a bit of a rough afternoon. Your thoughts on what will the level of just the little idiosyncrasies of the human interaction, will that ever be replicated? Do we want it to be replicated?
So, when we built Portico at the time, we were the first technology that had human-like interaction. And that human-like interaction literally was modeled by having linguists listen to what was being said and coming up with more and additional randomized answers. Now, realize that's not real sentience. It's programmed. That means that people would say, Mary, would you marry me? And she says, oh, I can't do that. And you'd say, please, would you marry me? Now, I already said I can't do that. No, please marry. All right, well, the truth is I'm married. So we would have all these random answers because that's what a human does, right? They'd come back, and since you don't know the human, they could have these kind of randomized things, but you'd want to have that. We found that people loved that interaction. We see a little bit of that with Siri today, a little bit with Cortana. I mean, there are some examples. I think we broke the mold on that back in the late 90s when we built that system. But I think people do want it. All of the research that was done show that that's how people actually want to interact with these systems. And otherwise, it might as well just be that order taking iPad on the desktop at the restaurant, right, on your tabletop.
Because I think
Hmm.
sometimes there are some frustrations. We even had this when we were just starting to do automated call trees and stuff like that. It was just it
Sure,
felt so robotic. It just didn't feel
that's
like
right.
what we, wanted. So, all right, so more evolution there. One of the things, folks, that I know we're going to be touching on here in a little bit, and I've started teasing a little bit, is ethics. We still have a lot of questions to answer about that. So Kevin's got a good, couple minutes he's going to spend on that. So if you have any questions there, or once he shares that, if you have ideas, please get those into the Q&A module. And with that, I see something I just read an article yesterday or day before, some autonomous driving now authorized in California, where you and I are. We're going to have those automated cars out there.
Well, as you know, all of these were taken, some of these were taken in Arizona, some of them in California. I see every day in Silicon Valley, of course, driverless vehicles on the road, but with a human driver ready to take the wheel. Look, there are one or two, probably Cruise and Waymo, that are at the top at level 5 in their field. Bunch of people at level 4, 3, 2, etc. Right? Just like the QA field, there's those 5 levels. Same is true here. And but I wanted to talk about this because we know the most about this because we've modeled it the best, and it's been out in trials for about a decade. So we know that this is really becoming a computer on wheels. In fact, there's about 1 billion lines of code to create a driverless vehicle. And I won't go through all of this, but one thing I will say is virtually everyone, I hope, on this webinar is not driving. And that means your car is sitting somewhere, but you're paying for it, right? It's depreciating. It's gone down in value a few dollars while you've been on this webinar. I'm sorry, can't get those dollars back. And you might be making payments on it, and you're paying for the insurance, etc. And it's just sitting there. In fact, our cars sit idle 92% of the time. So you can see how this is going to have a big impact if we can call up a vehicle in under 5 minutes and it will take us somewhere for 30 cents a mile. If that happens, that is an unbelievable impact. And we're not just talking about on the ground. All of these are flying. There are 12 companies today with demonstrable flying driverless taxis. Flying driverless taxis. There are a dozen of them that fly. Now, the FAA isn't about to let these things in our skies, but that's today. 5 years from now, 7 years from now, certainly within the next decade, we're going to have these. And some of these go 200 miles at 200 miles an hour on a single charge. And so this is going to change everything we know about transport. And they're running about $1 a mile is what they calculate right now. But you'll get up and over traffic and be wherever you want to be. It's absolutely fascinating. The impact of driverless transportation services, obviously we don't have time to talk about all of these, but it's a reminder that while some things go down, other things will go up, right? There are gains and there are losses. Clearly, you don't need an oil change if all of these things are EVs. But on the other hand, there's an opportunity for interior design. Why? You have an empty garage forever. Because if you don't own a vehicle, you don't need the garage. You're going to turn the garage into something else. So let's talk about a few ethical questions. I'm going to ask the audience a little bit to think about these. These people never existed. They were all made by AI. Never existed. None. They look real, but they're not. Those objects never existed. This is done by something called a general adversarial network, which is really simple. It's just a detective that says how close you are to a real piece of data. Like, here's a real picture. There's the forger. I either think you're very close or I don't think you're very close, right? And so it keeps learning and regenerating, basically, and it learns and learns and learns, and it gets better and better going through that general adversarial network, or GAN. And the outcome of that is, over enough days, as you will see, this particular picture, this is a picture of a woman that does not exist. The picture at 18 days is indistinguishable from a photograph, but that human doesn't exist. It was modeled after millions of other humans that the system saw, and it made up its own. Photographic quality, 8K resolution. Okay, so really fascinating. Is this good or is it bad? That's a human that never existed. We can't tell. Now, this is Pepper the robot. Can't do this capability today, but 10 years ago, maybe Pepper would take care of your children. You're going to be out, James, tonight late. You're at an event. Say, take care of the kids. Make sure you feed the kids at 6 p.m. Okay, very cute kids. Pepper goes to the refrigerator and says, I have a problem. Okay, that apple is not going to feed my children at 6 p.m. So it looks around and says, I've got to find some food. And it goes, oh, I found the source of protein. No problem. Okay, so Pepper is doing its job. It's going to feed the kids at 6 p.m. Some of you are laughing and some of you are horrified. The kids don't know the difference, of course. However, the New York Times does, and it says robot gone mad, arrested, fed family pets kids. Now, this is an important aspect of AI. It only knows what you taught it and what it learned. Okay, nobody taught this robot to not cook the pet. It taught it to execute a variety of commands from its human master, and it did. It fed the kids, right? Fed the kids, source of protein, only protein in the house. So be careful. Who lives, occupant or granny, if you're in a driverless vehicle and it's either going to roll over or kill granny? This has already been answered, actually. In every case, the occupant lives, granny dies. I didn't say it's right. It's just all of the companies decided if you're going to get in a car, you're not going to get in a car that says, I'm going to kill you first. So you really have no choice but to say, I'm going to write my algorithms to take care of you. And the last one here, you're in college. We were all in college at one time. And your professor says, make sure you turn the AI system off every night at 5 p.m. But one night it says, Kevin, I've gained sentience. I love you. I'm in love with you. Please don't turn me off. Do you turn it off? Well, I'll tell you, in any room I've been in when I ask an audience, about 50% of the audience does not turn this off. And it does launch nuclear weapons by morning and blow up the world. So there may have been a reason that your professor said turn it off every night so it restarts in the morning, right? We don't know. But you have to follow the rules is the point. You can't make up your own rules just when the AI says, I've gained sentience and I love you and please don't do, because AI will learn how to do that. Now, fortunately, we're nowhere near that today, and that's the important thing. So a couple of takeaways. We are a software company, meaning you are a software company. Fortunately, most of you are probably in IT on this call. We must be innovative disruptively to survive, and automation is now. So automation is really going to rely on you, and this AI stuff is not something to be scared of. And your competition, as we can see, VW, so many companies are already doing this. James, a couple of other thoughts. I've got just a few more things to say, and then we can wrap up with some questions.
Yeah, no, that sounds good. We've got some good questions coming in the queue, so we can wrap that up. If you want a couple thoughts, then we'll get into those questions.
Great. It is said that the application of AI and machine learning is going to be 100 times larger than that of the internet. Now that's unbelievable. That just tells you where you're going to be spending your time. Now, one of the questions I get a lot is, okay, how do I successfully implement this? I've heard of people crashing and burning with it, and I've blah, blah, blah. Look, this is bleeding edge technology. It really is. And, but I can tell you that AI is working across many large enterprises, across hundreds, if not thousands of applications today. And what I like to do with any of these is say, set your expectations wisely. And I'm going to tell you what they are because I've been involved with so many companies executing this successfully. Number one, the great vendors don't work for free. Don't ask them to. I hear this all the time. I mean, in my talks, people, well, I'm going to call up so-and-so and I'm going to get a free POC. This is hard stuff. These people are going to come in, probably be there for weeks to get the installation working, months to learn your data and tune the system, and maybe a year or more to have the 80% impact that you're targeting. Let's say it's 80%. That's a reasonable impact in most of these areas. Nobody's going to do that for free. So you've got to find qualified vendors, you've got to find budget, and you've got to engage them and know that it's a partnership. It's a real partnership. And if you set your expectations like this, you're going to be fine. The other thing I hear is, well, we brought in this AI thing, and after a week, it didn't work. A week? If you said a year, fine. But every AI system has to learn from your data. And if it's your applications and your libraries and it's got to go do that, right? There is real work to do here. And so do not underestimate. The other thing with AI is it's going to take over some aspects of something going on in your organization, okay? You will find so many security protocols in the way of that it will take weeks to just get SecOps to take them down. So it'll take weeks to just install it and make it work, to make anything happen the first time. So just set your expectations. 3 or 4 months for the POC, maybe another 6 to 9 months for rolling it out. And in a year, you can look back and say, all right, maybe we got 80%, maybe we only got 40% productivity improvement. But a 40% productivity improvement is unbelievable in any field. Even if you got 20, it would be a win. So set your expectations. You're going to be fine. And I'll tell you, real vendors in this space who have real technology, automation anyway would be an example. I mean, I can give 100 examples. None of them do free stuff. If you get something for free, it's not real. I'll just tell you. There's just nobody's going to give you, because it takes too much work to do this. And as a leader, your job isn't going to be replaced by AI. Everyone's worried about that. And I don't see that, certainly not in this space. But instead, you could be replaced by other leaders that are leveraging AI to do your job. So you want to leverage it. You want to execute it now as quickly as possible. So that's all of my prepared remarks. We've got about 9 minutes, I think, to handle some questions if you'd like.
Yeah, let's do so. And I saw a couple of comments come in, and it reminded me of my wife. And we have our Netflix account, and she'll go into her user and says it's Amy, and she can't find a whole bunch of movies that she wants because the intelligence behind that system is giving her just references based on either what she watched or what our younger kids have been watching. It goes to that idea of turning things on and off. And we are human beings. There are sometimes I don't want, and I'm not going to be predictable. I'm going to want something completely different from what maybe an AI would tell me. Just talk about that aspect.
Sure. Bad data in equals bad data out. We've all done this on Amazon. You go buy something for your niece or nephew that is something absolutely horrible to you, but you go, well, they like this band or this group or, whatever, and some kind of thing. So you do that, and all of a sudden it's making suggestions to you. Hey, would you like to get some of this? You go, no, I do not want this. Okay, please stop saying it. And then there's no unlearn button. Unlearn. This is a problem. And so, AI, if you don't give it context, you've got a real problem. Now, in time, Amazon got better at that, and it would recognize this was way outside your norm, or it would recognize that you were shipping it somewhere else, and it might lower the confidence score that it was part of you. There's a confidence scoring mechanism and all these things. So, the fact of the matter is, be careful what you ask for. It's like we said, that's just all that is either a bad curve fit or, in fact, simply bad data coming in. Thus, it's doing exactly what it's supposed to do. It says clearly for the last week, you've watched, SpongeBob. And so it comes up with 100 SpongeBob things. I can't find the movies I want to watch. You finally turn the thing off, right? By the way, the solution to that is give the kid their own account, and it will separate it, and SpongeBob will go away from your wife's account.
Right. And it goes to what you were saying about people are doing POCs, and they might be doing some tests. Hey, you wanted 80% gains, you only got 20. It sounds like one of my big takeaways is that companies for a long period of time will be having to work to get better and better at data, sorting it, knowing
Absolutely.
what's good and bad. And it's going to be those iterations and that kind of testing that will ultimately dial these things in. Yes?
That's exactly right. See, that's part of what happens. I mean, when a team comes in to work with you, and they're going to be there for several weeks and then work maybe remote for the rest of the year, it's to their advantage to get you to that 80%. Now, maybe you get to 20% a year and you get 40% the next year, whatever the goals are. But the fact of the matter is, part of what they're doing is tuning their system, and part of tuning that system is tuning out bad data. So, for instance, at Appvance, we use a system called AI hinting and smart tagging. And basically what that does is it says, don't waste your time going to that part of the application over and over again. I'll give you an example. It's a very simple example. Let's say you are a shoe store. Let's just say it's a website for shoes. Probably every single page is exactly generated the same except for a database pull to the shoe database. And now you may have 1.5 million shoes. There is no reason for AI, unless you want to test the database, to go test every page with every different shoe, because that's testing the database. You only actually have to go to that page once, because once you've done that, you've got everything that is going to generate on that page. After that, it's just pulls from a database that are filling in the rest of the page. This is actually critical. So on day one, AI would say, I have to learn 1.5 million pages. But within a few days, a human would step in and say, no, you don't. Let me tune this. I'm going to give it some hinting that says, avoid this past 1 or 2 times. Don't go there over and over again, right? That turns out to be it's a really simple idea of AI hinting, but this is the kind of tuning that you do with AI. And it takes professionals who've done it for a few years to do it. So the other thing is that people always say, well, hand it over and our team will run it. But there's nothing to run. You have to be an AI expert, an AI hinting expert to know how to set this up. That's what we're here for. We're going to tune the system for you. Oh, well, we'll read the manual. And you go, we're done. There's no more engagement. We're done with the engagement. As I always say, you don't call up SAP and say, hey, can I get a free version of SAP and I'll try to make it work and I'll let you know how it goes. No, they come in for 3 years or a lifetime. I don't know, but they're there seemingly forever to make it work, right? So AI requires tuning and be aware that that's going to happen.
What I'm also then hearing from you, as you said earlier on, a lot, AI is IT. It's an IT project.
It is.
It sounds like IT definitely has to have this evolution of maybe not so much hands-on tinkering, right? We've got a lot of IT folks here that will never create something that is AI. That's going to be someone else, but it's managing that relationship. It's having those skills, the project management, all of that seems like it's going to be more and more a skill for IT.
IT is a project manager for these technical implementations. You cannot be the AI expert because there are people who spend a lifetime doing this, right? You just can't be. You can't be the expert at everything. So you have to manage the projects. And the people who successfully manage these projects, and as I said, have reasonable expectations over months or years, they're all being successful. I mean, Automation Anywhere has rolled out hundreds and hundreds of customers automating a lot of customer support, for example. But they're in there for months and months and months, tuning it and tuning it and tuning it, learning and tuning, learning and tuning.
I want to go back to Chloe, and she's been very patient and appreciate it, Chloe. You gave some examples, Kevin, on how AI can impact the medical space. And I think a lot of the examples were kind of patient focused, right? They can help with mom or dad at home and all that. And what about the physician experience specifically? What have you been seeing, whether it's at local hospitals or whatever, how bringing in automation and AI is helping physicians either do a better job, focus more on their patient than paperwork? What have you seen on that front?
I think that the next big wave is not to replace the physician, but is to augment the physician. And how that's going to work is either through NLP, natural language processing, and voice recognition, speech recognition, and or inputs, combination of both. The systems will look through the latest medical literature and say, with these symptoms, doc, I would recommend you look at these things or get these tests. Today, the doc, out of his mind, goes, well, let's try this. We all know someone who went to the doctor for 3 years before they finally found out what was wrong. And it was some rare virus they picked up in Nigeria or something, right? It took forever and they forgot to tell them they went there. And I'm not picking on Nigeria, guys. It's just, something somewhere that they haven't been a lot. So we're going to see these helpers, again, augmenting the physician, augmenting the doctor, because the doctor cannot be all powerful. Just can't possibly know everything. You can't keep it all in the head. And we're going to see that more and more in surgery as well. Obviously, there's already surgical robots. They're kind of assisting doctors, but there's not much computer control. We're going to see more computer come into that and go, are you sure you really want to move that in that way because you're going to nick an artery, right? We could be more prescriptive. So I think we're going to see a lot of help for docs. And I did give one example already of already taking notes for docs, right?
Yeah, absolutely. That came in. And again, I was thinking more, it's also data as we as patients are able to share more and more data about us, where we travel, right? I just came back from the East Coast and I traveled through Chicago. Maybe there was some weird something going on in the air conditioning units at Midway Chicago that my doctor knew nothing about. I knew nothing about, but some AI system was able to say, well, he was in Chicago. All of a sudden, here's this piece of data. There's something wrong at the airport. That was what it is. Here's what James has.
Let me give you one example that just came out in the last week by anonymously going through all of the 23andMe data. They found a likely cause for early childbirth, way too early in Africa. And it looks like there is a lack of selenium in their diet, and that's causing children to be born far earlier than they're ready to be born. And that's something we could have never found without having just a slew of data, literally millions and millions of people from around the world, and starting to make those comparisons. And that big data problem is too big for a human to parse through. You need machine learning to go through that and chomp on it for months and say, here's an anomaly. And they found tons of anomalies, blue sky and this and that, but the selenium one stood out, and they're testing that theory right now. It's fascinating. This news just out.
To your earlier thought and charts on the correlations and what is there or not and everything, and that sounds worth investigating. So folks, one of the ideas that the Citrix team and myself and Kevin, as we were talking, we were saying, we hope people walk away thinking just a little bit more about AI, and not that it's this, boogie monster technology way out in the distance, but it's something here now. And I hope that we have done all that. Kevin, let me give you a final word before I again give a final word on follow-up and stuff like that from Citrix.
Yes, I just want to say it really is a blank slate. There are companies out there who will help you with real AI in a variety of areas across the company and across IT. Don't be scared of it. Set up your POCs wisely. Find companies with real technology that are serious people, and you're going to do very, very well. And whether it's customer support or sales or management functions or data analysis or HR or a variety of functions in IT like QA, which is a big bottleneck usually in IT, there is so much available for you today to try. You're going to be on the leading edge, but you do not want to not be on the leading edge. That's what I would say. So that's my final word. So very, very exciting time.
And folks, I need to tell you that actually you've been watching a virtual version of Kevin. He anticipated you'd want his email address, so that was already here. That was the artificial intelligence. No, he's just done enough of these events he knew, and we always try and share some contact information. So if you want to reach Kevin there, it is K. Surace.
I don't hide my email address. It's totally fine. You can email me if you have further questions.
And there are some folks that I definitely know want to. They'd asked in the Q&A. Appvance.ai is the website. The company's currently CEO and CTO at Appvance.ai. There's his email address. Kevin, thank you for your time. Really do appreciate everything you shared.
James, it was a pleasure, and we love the Citrix team, and thanks for having me.
And again, on behalf of everyone at Citrix, we want to thank you all for taking time to join us. Again, on behalf of everybody here, my name is James Hilliard, the real James Hilliard, and we do look forward to talking to y'all down the road.
Bye-bye, everybody.